Okay, is it working now?
Yes, yes.
Okay, good. Thank you. So before I start today's lecture, I want to remind you that there's a midterm evaluation for this class, and I really hope that all of you can fill that out so that I can get the feedbacks for this course. Um, so that should be on E3, and you can finish it online. So please, that would be really helpful for this class and my teaching. Thank you. 所以就是我们有那个其中的评量，或是其中意见回馈之类的，然后它应该是在E3上面会有，就是那个线上的表单啊，我们就是就是需要大家去帮忙填这个东西，那可以提供我们一些回馈，它对这个课程还有我的教学都会很有帮助。谢谢。And so today we're moving to the topic of machine learning for brain computer interface. Uh, so, uh, so since machine learning is a broad topic, so we're not gonna talk about a lot of details of machine learning. So we will focus on the background knowledge you need for understanding some of the machine learning techniques that we're going to use for decoding EEG in brain computer interface. So I will start from the basic concept of machine learning. Uh, since in this course we don't require you to take the machine learning course in prior. So I will go through the basic concept of machine learning and describe what types of machine learning are there currently and talk about some classic methods. And then we will um, have a recap on convolution and some signal processing so that we can talk detail of the CNN for EEG decoding next week. 好，那machine learning 是一个很大的题目。那因为我们这个课没有要求同学需要修过机器学习，所以有一些同学可能没有修过机器学习。那我这边就会先讲一些非常基本的概念，然后介绍一些machine learning 相关的一些基本背景知识，然后为的是让你之后可以有办法理解我们所要用的在 EEG 分析还有脑机界面上面所要用的 machine learning 的方法。OK，and and so I have uploaded the video of the complementary material for last week. So that's mainly about TRCA, the task related component analysis. That is the state of the art um, algorithm for SSBP decoding detection. And since we have a final competition of BCI vehicle control, and we will provide the um, SSBP stimulation for you to use SSBP to control the vehicle. So I highly recommend that you um, take a good look in TRCA as well as other SSBP detection methods like the classic CCA method. Um, and so we will provide the CCA algorithm, including the frequency bank CCA, which is the state of the art training free method for SSB detection. But if you want to achieve a higher accuracy, you might want to try training based SSBB detection using TRCA that will significantly improve your accuracy. So it's worth a try. 那之前我上传了这个 TRCA 的影片 Test Related Component Analysis，那这个是那个关于 SSVP 分类的一个 state of the art 的方法。那我们到时候因为期末有这个 final competition，然后我们要用 SSVP BCI 去控制车子。那我们会提供这个 SSBP 的 presentation，就是视觉刺激，然后还有就是经典的这个 FBCCA 的方法，那它是不需要经过圈领的一个方法。那所以那样子的话，你就可以去 implement 一个 SSBP BCI，然后去控制车子的移动。如果你想要达到更好正确率的话，你可以考虑使用这个 training base 的方法，意思就是说你需要先收集一些 training 的资料，然后才能用这个方法。那个 TRCA 就是 training base 的方法里面目前最好的，所以你如果用了这个的话，你可能就会看到很明显的正确率的提升，所以值得一试。Okay, so here I'll start talk about machine learning here. So first, let's think about what learning is. So learning is a process of acquiring new or modifying existing knowledge, behaviors, skills, values, and preferences. So this is definition given by this literature, and machine learning, this is from Wikipedia, is a scientific study of algorithms and statistical models that computer systems use to perform a specific task without using explicit instructions, rely on patterns and inference instead. So if you want the computer to do something, uh, rather than giving the computer um, instructions, you use the method so that the computer can do this task by itself. And the machine learning, so to allow the computer to do things like that, you need to design a machine learning algorithm, and it's mostly built upon models. Uh, so the models is a The model is a computational process where you have input for the model and it gives you the output. And so what's being done inside relies on training of using the data. So the machine learning is about that a machine learns something from the data. So the data for the machine to learn is called training data, and that will help you train this model, and it will make the predictions or decisions without those explicit instructions. 好，所以这个 machine learning 它就是要有一个，你要让那个机器去可以自己去做一件事情，然后然后跟怎么讲，就是你要电脑去做一件事情，你可以给它指令，就是你叫它做什么它就做什么。但是machine learning 的话，就是你要先让机器去学怎么样做这件事情，然后之后它就自己去做这件事情。那我们这个 machine learning 用的方法，通常就是需要有一个 model。那这个 model 它会包含了这个怎么样的 input 会产生什么样的 output。那这个演算法本身呢，需要靠资料去学习。那所以我们就让电脑给它一些资料，然后让它去看，然后试着去了解这个资料的一些特性啊，或者学到里面的一些 pattern 什么的，然后它就可以去 照着你的 model 然后去产生这个 output 的 prediction。So we've been heard about AI, machine learning, and deep learning. So AI stands for artificial intelligence. So in the concepts, AI has a most general concept that talks about a program that can sense, reason, act, and adapt. And while machine learning is about the algorithms that the computer can learn from the data and do a specific task better and better. So deep learning is a specific area within machine learning. So it does the things of machine learning, but it's limited to using some deep learning techniques, like you design a neural network for the computers uh, as a model to learn the data. So that's their relationship. So the computer learns things from the data. And what is data? Data is a set of values of subjects with respect to qualitative or quantitative variables. So here you see variables. So data is a set of values with respect to variables. So when we see a data, we will see what variables are there in the data and what values it contains within each variable. So what are the differences between data, information, and knowledge? I'd like to invite someone in the class to answer this question. Okay. Any volunteer want to answer? So whatever you answer in the class, you can go to the TA after class so that they can record the the participation bonus. Muting,
Hi.
hi.
In my opinion, I think first of all, data just maybe just some numbers. Information is when we analysis the data, we will get some information, and the knowledge is according to the information. After our thinking, or maybe more analysis, and we can conclude a knowledge.
Okay, that's brilliant. Yeah, it's surprisingly you almost say what I want to say. So I want to further ask you more. So could you give an example for us to have a concrete idea about data, information, knowledge?
An example.
Yeah. To talk about it might be like some number, some values. Is there an example?
Um, I have no idea now.
Give it a try. Anything. Yeah. It's actually everywhere in our life.
In our time.
Yeah.
No, I only can think about experience when if this experiment is my only way to contact about data.
Uh-huh. You say experiment?
Yes,
So you've been doing experiment that use data.
yes, like physical experiment.
Uh-huh. Could you talk about that?
Yes, like when we do physical experience, maybe just some measure, but we first of all we don't know what the meaning of this measure number. But when we multiple something or yeah, I have no idea.
So you mentioned physics experiment. So do you want to let us know what physics experiment you have in your mind?
我们试试看中文，
嗯，没问题。
像是做物理实验的时候，就会很常说，他先不告诉你公式是什么东西，然后就会先叫你可能测测看这些东西啊，然后让你撞撞看。
测什么东西？所以是什么样的物理实验？
就是像是我们之前在玩测光速，
测光速。
对，然后就会知道一些，就是例如说你就去量量看说有什么折射，可是他不告诉你折射那些是什么，然后试着用原本知道的光速这个数字，然后看他们能不能去跟我们测出来的 data 去凑出一些像是 information 的东西，然后再用这个东西，可能至于市场数啊，然后就可以可能发展出一套自己的，就是像是理论的东西。上次做的。
OK，所以OK，所以你们这个实验，你们让光通过一个会折射的材质
一个大的水箱。
然后你们要测的东西是什么？
我们要尝试就是自己推出怎么测光速，就是虽然他给你一个数字，可是你要自己让它测出光速。
这样你们要测的是什么角度吗？还是
对
OK 测角度，折射的角度。然后你们会这样，你们需要自己先去想一个公式，然后得到角度跟什么的
因为
关系吗？
那时候是都不知道公式的情况下。
嗯，OK，所以你们会测到一些角度，然后这些角度可以告诉你什么？
可能例如说尝试看看套不同的东西，就看到角度，你会想要试试看，三角函数，就再看三角函数，说不定不小心就测出来。然后就是，但是这些东西可能都还没有什么意义，就是可能各种试验之后的结果，然后最后再用可能已经知道东西或其他方法，然后来验说，哪一组是有可能成为真正可能的公式。
哦，OK，我没有办法马上掌握到，因为我不太确定说怎么样从那个折射的角度可以得到光速。OK，不过我在想，就是可能就是你们测到这些角度，然后呃，这样，
它是有点像是现场小考试，就是有没有让你那个底，有一点点小小的引导，所以没有到这么的位置。
OK，那我把它转成一个更简单的事情，就是说，呃，如果我们现在把事情变成说，我们看光有没有折射，就比如说我们要让机器去判断光有没有被折射，那它可能就可以先先去用它的感测的方式测到那些角度，然后接下来它就可以去嗯解读说这样子，它量到这个角度是不是算是有被折射，还是没有被折射？然后我们对啊，你觉得这样可以吗？
应该可以吧？我不知道。
Okay. Okay. So, yeah, thanks for Muting's example. Uh, okay. So, yeah, that was a good example that she talked about that in the physics experiment, they measured the uh, refraction of light, and that's part of the experiment to estimate the speed of light. And they measure the angle of the refraction uh, so that they can kind of develop the mathematical model for estimate the speed of light. Uh, so here I have another example. So this example is about if you need to stop a car, but the data you have was from the traffic light. So here, assuming that you have the data that describes what's the status of the traffic light. So here you can see red and a bunch of values. I'm not sure what that is, but the information here it shows that the south-facing traffic light on corner of Pitt and George Street has turned red. So here it gives you the position of this traffic light, and from the data you have, you know that this traffic light has turned red. And then if we move to knowledge, then this is a knowledge for the driver. So the driver will know that the traffic light the driver is driving towards has turned red. So that's the level of knowledge you got from the information you have. And the information was derived from the data. And then the wisdom you have from your knowledge is to stop the car. Okay, so for the machine learning, sometimes we don't really have the way to make the computers to learn from data to wisdom, but it would be relatively easy to let the computers to learn information or even knowledge from the data. So imagine that you're a teacher trying to teach the computer to do something. That's some kind of supervised learning. So here you will gives the computer the label data, and supervised learning algorithms allows the computers to learn the label data, and it will try to predict the label for future unseen data. So let's give a quick example here. Say you have a lot of pictures, so now the task is to recognize the animal you see in the picture. So you will show a lot of picture like the cats or dogs, or we can simplify it to be cats and not cats. So you give a bunch of pictures that's labeled cats, and also a bunch of pictures that label not cats to the computer, and the computer will ultimately learn to recognize the picture between cats and not cats. So this is a supervised learning. You need to have label for your data so that the computer can try to predict the label as accurate as possible. So the label here is cats and not cats. So some kinds of textual discrete label. So the classification can be uh, visualized like this. So this cross and axis R stands for the samples of data that you have. So let's say you have a six picture, and three of them are cats here, and three of them are not cats here. So the classification is essentially in the space of the data. You let the computer to find a boundary between the two set and two class of data. So that's classification. OK，那个 supervised learning 呢，就是监督式学习。那它是你就像是你要去教电脑去做一件事情。那比如说这件事情可能是分辨图片上的东西。那图片上的东西这边的例子的话，就是说你可以去区分图是猫或是不是猫。那你就会给机器看很多图片，那这些图片，呃，它就会带有那个标签，就是 label。那这 label 就是猫或不是猫。所以假设我们这边有给它六张图片，那这张图呢，我们这个十字跟叉叉呢，代表就是都是图片。那不过十字这边呢，我们假设它就是代表被标签为猫的图片。那叉叉这边呢，它就是被标签为不是猫的图片。那我们把这个每张图片呢，在这个资料的这个数值的空间里面，我们可以把它想象成就是一个点。那所以这个空间里面有6张图片，所以有6个点。好，然后这6个点呢，在这边，那我们知道他们的标签。那我们现在要电脑做的事情，其实就是在这个资料空间里面去找到2个类别的边界。啊，所以这个边界它就知道说，边界的其中一边是猫，边界的另一边就是非猫。所以这样的话，这3个资料就会被认定为是猫，这3个资料就会被认定为是非猫。So that's supervised learning. So uh, we just gone through the we just went through the process of training of supervised learning. We gives the machine the pictures, the data as pictures and their labels, and then the computer will find the boundary to separate these two cases. And what model can do is to predict. So say you have more pictures to come in, then using the boundary the computer just learned, it will start doing the classification for the unseen, the new pictures. It will depends on where the data, the new pictures lies in the data space. It will gives you the label. It will label the new pictures for you. OK，所以如果刚这样就是训练的过程，那如果那个模型训练好之后，我们就是要用，那用就是要去让它可以做预测。所以对于就是接下来看到的图片，没有 label 的图片，随便的图片，那他就会用他刚刚学到的东西去给这个新看到的图片给定一个 label，去 predict 它的 label。所以他就会告诉你说这个新的图片是猫或非猫。好，它这个就是测试，这个叫做就是prediction 去预测。那刚刚讲前面是训练的阶段，那所以也有分为训练阶段跟测试的阶段，就是 training phase 跟 test phase。然后也有人会说这个是 evaluation，就是说你去评估这个模型好坏。Okay, so after model training, when you give the model new data to predict, that's the phase of test phase uh, compared to the training phase. and we sometimes we call it model evaluation. So evaluation means that we're using the test data to validate the model performance in the specific task. And so the previous example is about cat and not cat. They are the label of discrete labels showing two cases. So there are other labels that's in the type of continuous data. For example, if I want to, so let's say our task become to predict someone's age based on the face picture. So what you want to predict is not some class or label. It's about the age, and age is a continuous value. It ranges from 0 to more than 100 because now human can live for more than 100 years. So the task becomes given a face image, then the model has to output with the age predicted. So that becomes a regression problem here. It will identify real values, and it could be age or it could be dollars, weight. And here, unlike the previous case in the classification, the model tries to find a boundary to separate data within the data space. Here, the model is trying to find a curve or a hyperplane if it's multiple dimension to fit the data so that you can see this curve goes through these data with minimal uh, distance of error. 好，那这边 regression 呢，指的是说我们今天的标签是一个连续的值，比如说我们要用一个人脸的图像去预测他的年龄，那年龄这个东西是一个连续的值，范围可能是0到100多这样。那所以就是这个 model 它的 input 就会是一张人脸的图像，那它的 output 就会是一个年龄一个数字。那这个时候跟前面的分类就不一样，它在这个资料的空间里面，它不是要去找这个用一个边界去把资料分成两边，不是，它就是要去看到这些资料呢，它要去找一条线，让它去通过这些资料，然后越近越好，就是它通过去的时候，就是这个距离上的误差越少越好，所以你就是希望说，这个线可以贴着这些你的资料，在这资料空间里面。那如果它是多维的一个资料，它其实就是在找一个多维的一个平面去拟合这些资料。Okay. Any questions so far? Okay, so again, the regression is about separating um, two sides, separating the cases of separating data of different cases in the data space. And regression is to finding a fitting curve that fits the data within the data space. So if it's 2D, then it could be a curve or it could be a straight line. Depends on the order of your, equation, and it could be a hyperplane in a multiple dimension space. So here we also can see there are different ways to fit your data in a regression problem. So here, the bottom left, this is to show that the order of your polynomial curve shows different effect of fitting. So here the dots are the raw data, and the curve are three order, fifth order, ninth order polynomial fit. When you have a higher order, your curve can um, have a more complex curving like this. If you have a low order, then it will be a less curving curve. If it's one order, then it's like a straight line. So you can see it's important to have a adequate order in your model so that you won't go overfit. The bottom right is the example showing the fitness of your curve. So here you have the data as circles, and you're looking for a curve to fit. So you might want to have a so here you can see the blue curve is a higher order fitting, but it shows some overfitting uh, that we can see that it fluctuate more, and that so even though it gives you a higher fitness in the training data, it might fail to give a better prediction for the predicted data for the test data。好，那这边 regression 我们就有这个一些例子，还是这个二维空间的话，你就是找一个直线去 fit；如果是多维空间的话，就是一个高维的一个平面，试图去拟合这些资料。那你拟合就是希望它的 error 越小越好。那这个 fitting 的话，你的不同的 model fitting 的效果会不一样。那这边的话，一个例子就是说，你的这些资料点被不同 order 的多项式的曲线去 fit 的时候，那你会看到你高的维度，呃，高阶的这个多项式的 curve，它可以比较多弯曲的变化，所以它可以去把这 training data 拟得很紧，但是这个不一定对那个 test 的时候是好的，因为你拟得太紧，你就会产生一个事情叫 overfit。那 overfit 的话，就代表说新的 data 来的时候，你会反而造成更大的 error。那比如说这边我们看到它的右下角这个图，我们看到这些图的这个点点是这样子。那相对于这个比较平滑的这个 fitting curve 的话，那蓝色的这个就有点 overfit。你可以看到它就是很不稳定的去试图去找这些最近的点。那当你的新的资料进来的时候呢，你就会发现平滑这个其实是可以给你更小的 test error。So comparing regression and classification, the regression requires continuous label, like some house price or other continuous label we mentioned like ages, the and like ages and temperature or something like that. And classification requires the discrete label, like the cat and not cat, name of the person, the flower type, and so on. So this is a broad view of the supervised learning. And now we're moving to unsupervised learning. So unlike supervised learning that you have labels in the data to allow the computer to learn to recognize something or to fit the data or to find a fitting curve for the data. Unsupervised learning is for the computer to automatically find the structure in the data so that it can extract some features that can represent the structure of the data. For example, you have the data samples in the data space like this, and you're trying to group them together. So from intuition, we need to um, have a way to group these data points. So we might just look for, we might measure the distance among each of them, and then we can circle those that has smaller distance for each other. So here we can claim that those data points with smaller distance means they are similar to each other. And then we circle this similar data together. So that's clustering. 好，那这边讲到这个监督式学习之后呢，我们接下来就可以看非监督式学习。那非监督式学习的话，就是它这个时候它就 data 上是没有 label 的。那 supervised learning 需要 label， 但是 unsupervised learning 就不需要 label。那它就是让机器自己去寻找这个资料里面的一些结构，那它代表的就是这些资料的一些特征、一些性质啊，不需要 label 也可以把它找出来。比如说这边我们想知道说这个资料可以怎么样去分成不同的群，那我们可以做一件事情，就把这些 label 之间的距离把它找到。那我们就假设距离小的代表这些资料有它的相似性，所以这个 data sample 之间的相似性如果高的话，我们就把它圈起来。意思就是说，距离小的那些点，我们把它圈起来。那我们就这边圈圈圈，我们就圈出了3圈。那我们可能就可以说这 data 是有3群。那我们还不知道各群是什么，但是我们知道它是有一些分群的。So one classic clustering algorithm is k-means algorithm. So first, you need to have a prior setting is that how many clusters you think there are in the data. So here, this is the data distribution in the space, and you assume that there are 3 clusters in data. So you can see the k-means is to spread the means. And the k-means is an iterative method that tries to find the best fitness for the 3 cluster. 好，这个 k-means 是一个经典的这个分群的演算法。那它的做法就是你要先猜测说资料里面有几群。那它运算的过程呢，就是它会先，如果你猜测有3群啊，像这个例子里面，你猜测有3群，你就先放3个命值在这个资料上。那这边命的值指的事情其实就是 cluster 的中心，就你认定说有3个群聚中心在这边，好，那你就先放上来。然后呢，它就会有一个演算法呢，去找这个群聚中心怎么样去瓜分这个资料。好，那它是这个迭代的方法，所以它会先做一次瓜分，然后针对当下的这个瓜分，它会去测量说，是不是每个点它有被分到跟它最近的那个群聚中心。那如果你发现说这个资料里面有些点它其实怎么讲？这资料里面有些点它应该在哪？就是他们会先瓜分一次，然后瓜分完之后，你就会发现说这个群聚中心并不在它被分到的那些资料的中心点，代表说 它分到那些资料，有的离它是就因为它不在中心，所以就变成说，整体的这个距离的加总并不是最小，那所以它的这个迭代就可以再继续，他们就会，他就会把这个群居中心再调整到，刚刚我们想要找到的就是该群的中心点，他就移到那边，然后再做一次瓜分，然后看说这个新的这个位置是不是有确保说整个群聚的整体距离的加总是最小的，然后就这样一直迭代到说它这个确实都落在这个自己所属的那一群的中心点的时候，它才会停下来。Okay, so the k-means first you have to create a number of means and spread it on the data space. So here the example has three means uh, to separate the data into three clusters, and it will do this iteratively. So first iteration, you just randomly put the three means, cluster means uh, in the data space, and then it will separate. So these three will separate the data into three regions, and then it will calculate if the data points within the same region uh, there's a so it will calculate the cluster center for each cluster and see if the mean you just assign lies in the cluster center. So usually it will not lie in the center at the beginning. So it will adjust the position to move the mean to the new cluster center, and then do the separation again and see if the position really lies in the uh, cluster center. If it does not match, then it will iteratively repeat this process until uh, the position lies in the lies at the cluster center within very very small error. Okay. So any question for the k-means? So here you can see this is a animation example. So from the beginning, you can see the cursors like this, and then it will gradually converge to an optimal position that separate these data into three clusters. Hierarchical clustering is easier to understand. Uh, you just look for the distance among your data and you're trying to group them with some criteria. You can start by looking for the closest pair. And for example, here the dot that's closest to one is two, so you will circle them together to create a linkage among them. And here you have five, and the closest is six, so you circle them together. And you have three, four being circled together, and seven, eight circled together. And then next, you look for. So now you have a group of one, two, and three, four, and five, six, and seven. So what's the next group? Uh, so the closest pair is when you have one, two, and five, six, and three, four, and seven, eight. You calculate the distance by the closest dot between clusters. So here the distance of 1, 2, and 5, 6 is the 2, 5, the distance between 2 and 5. And the distance between 1, 2, and 3, 4 is the distance of 2, 4 or 1, 3. It seems these two are the same. So in that case, you can see that the distance between 2, 5 is smaller than the distance between 2, 4. So for the group 1, 2, uh, the next grouping will be with 5, 6 rather than 3, 4. So that's the single linkage clustering that looks for the closest pair between clusters and create a larger cluster. So then that's one way to do that, and the other way is to find is to have another way to define the distance between clusters. So the previous one is defined by the closest pair in the clusters, and you can use the farthest pair in the clusters. So now the distance between 1, 2, and 5, 6 becomes the distance from 1 to 6. And the distance between 1, 2, and 3, 4 is still 1, 3, or 2, 4. So here you can see the distance 1, 3 is smaller than distance 1, 6. So in the farthest pair, you have a different way to circle. Now you choose the 3, 4 group to be the next grouping with 1, 2. So these are two ways to do hierarchical clustering, and there are also others. And and the difference is mostly about how you define the distance between one group to another. So there is another way called average linkage. Then it will calculate the mean of 1, 2, and mean of 5, 6 to calculate the distance of centers as the distance between groups. 对，那个阶层式的群聚呢，它就是会把距离短的东西先圈起来。那如果你是一二这两点，它就会先圈这两点。那它的差别，这个阶层式群聚的差别会在于说，它怎么样去定义两群间的距离。那像这边它可以有一种是 closest pair，那就是 one two 这一群跟五六这一群的距离呢，被定义为两群中距离最短的两个点的距离，然后就是2跟5。那还有另一种的定义法是说，两群中距离最远的两点的距离，那就是 farthest pair，那这个是 complete link cluster。那这样的话，1、2跟5、6这一群的距离就会变成1、6。好，那所以这个就会影响到他们凑成小群之后，他们怎么样继续凑成大群。那像如果是 single linkage 这种的话，它就会下一个它就是跟5、6做群聚，而不是跟3、4，因为2、5的距离比2、4更短。那但是像这边呢，因为1、6的距离比1、3要长，所以它就是选择跟3、4先连接，而不是跟5、6。好，所以就是不同的这个群聚定义方式，导致它这个阶层的这个划分不一样的结果。So hierarchical clustering has been used in many different areas. For example, this is a clustering of gene expressions. You conduct lots of experiments to measure the expression of genes, and then through the clustering, you can kind of relate the genes that have similar traits and to using this data. So you can see the genes that these genes kind of separate into two large groups where you have similar genes here and the other group of similar genes here. Okay, again, we see principal component analysis. We talked about this in the previous lecture about feature extraction. So it's unsupervised learning because you don't require any data. So PCA just look for the projection that maximize the variance of your data. 好，所以那个 PCA 也是一个非监督式的学习的方法。那它就是会，它不需要任何 label，那它就是你给它一笔 data，它就去想办法找出里面最大的变异。呃，它就找出一个里面可以得到最大变异的投影。So to summarize the the procedure of doing machine learning, first you need to have a problem. You need to define a problem. And based on this problem, you start gathering the data and you prepare the data to make the data complete and accurate. Then you can choose a model to start training. And once you have a trained model, you can evaluate your model using test data or unseen data. And then you can further optimize your model. For example, if you see the model goes overfitting, which means it has a very good training performance, but the performance is poor when you evaluate the model using test data, then that's when you need to tune your model. So if it's a polynomial fitting, then you can change the order of your polynomial curve. So that's parameter tuning. You change the parameter to make it to have a better training and evaluation. And at the end, you will have a satisfactory model for you to make prediction. So I think I just skipped the break because I didn't hear the bell ring. Can we take a break and continue at 11:20?